Well, in this next example, we again are going to find the rational roots, and then we're going to solve the polynomial for its roots. So I have the polynomial listed here, and I start with what is the degree of the polynomial? Remember, the reason I'm asking this question is because if I know what the degree of the polynomial is, then I know how many possible roots to be looking for. This is again a third degree polynomial, so I will have at most 3 real roots. Okay, that's what I would be looking for. Now I want to come in and I want to list the potential zeros using P and Q. P comes from the constant in the term, the last term. Q comes from the coefficient of the leading term. So I want to know what are the factors of 4. So for P, that looks like plus or minus 1, 2, and 4. For Q, that looks like plus or minus 1 and plus or minus 2. We haven't had to, up until this point, really deal with a ratio of P over Q, which is what we're looking at now. I do, because in my previous 2 examples, Q's been 1. Well, that's not the case here. So we come up with the ratio of all my P terms divided by each of the Q terms. So this is going to be plus or minus 1 over 1, which is just 1. 1 over 2, which would be 1/2. Then we start over. 2 over 1 is just 2, and 2 over 2 is 1, which we already have represented. Now we move down to this one. 4 over 1, which is 4, and 4 over 2, which is 2, which is already represented. So really what we gained, instead of just 3 potential roots, we have 4 because we have a 1/2 written right here. So I'm going to put this into the calculator. I'm going to look at the graph, and then I'm going to use the table to check for my roots. If you look at my calculator, you can see that I have this on the y1, and I wanted to just graph it to see. Remember how my degree told me I have 3 possible real roots. Here's the graph of the function. It's rather zoomed in, and I can tell that because my graph is not crossing over any of these tick marks on my graph, that I do have 3 roots. None of them are going to look pretty. None of them are going to be really nice integers, so I need to be aware of that. Okay, so when I'm going to come in here, and now I'm going to use the table. We had plus or minus 1, plus or minus 1/2, and so forth. So if I put a 1 in here, I don't get a 0. How about a negative 1? Still no 0. Now I'm going to do 1/2. Ah, that's where I get a 0, don't I? 1/2 or 0.5. That's the root that I'm going to use. So I know that when x is equal to 1/2, I have a 0. So my root, and I'm going to write it right here, x is equal to a positive 1/2, and then I like to come in and write it in its factored form so I kind of keep up with what I'm doing. Now we're going to use synthetic division. I'll leave that up there. Let's use synthetic division to simplify this by its factor of x minus 1/2, right? We're kind of whittling it down. So we're going to take the 1/2, put it upside down, and write the coefficients of my polynomial. 2, -5, -6, and 4. Don't be afraid of the fraction. It usually disappears in what we're doing. So I have a 2 that I bring down. 1/2 times 2 is just 1, and I add straight down and get -4. 1/2 times -4 is a -2. Add straight down and I get -8. 1/2 times a -8 is a -4, which is what I wanted, because if 1/2 is really a root of my polynomial, I should get a 0 here. Remember that my third degree polynomial, so this is the coefficient of my leading term, which is a third degree, or x cubed. When I divide it by x to the first, this becomes 2x squared minus 4x minus 8. I have a quadratic that I can in fact factor now. So let's put this together and do a little factoring. So I'm going to rewrite my function with what I know. my original factored root of 1/2, right? That was the first one we found from our potential list, times this quadratic, which is 2x squared minus 4x minus 8. I know that I can factor this trinomial right here, but I'm going to, and I can do it using trial and error. Before I do that, I am going to factor a 2 out of the trinomial to just reduce this, right? That's a greatest common factor, and you should always try to reduce your numbers as much as you can. So I have x minus 1/2 for the first factor. I'm going to take a 2 out of this, leaving me with x squared minus 2x minus 4. So when I attempt to do trial and error on this, that looks like x minus x plus, right? Because that sign tells me I'm looking for opposite signs. So I want to know, what are the factors of 4 that subtract to give me 2? Again, what are the factors of 4 that subtract to give me 2? There are no factors of 4 that subtract to give me 2. So that tells me that instead of doing trial and error, I now have to do the quadratic formula. Let me give myself a little more space here. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Remember, I told you that these roots weren't going to be pretty. Okay, so now let's figure out what x is. So b is a negative 2, so I have a negative of negative 2 plus or minus the square root of negative 2 squared, whoops, minus 4 times a, which is a 1, times c, which is a negative 4, all over 2 times 1. Simplifying this, I get 2 plus or minus. Under the radical, I have negative 2 squared is 4, and then a negative 4 times a negative 4 is positive 16. So this is 16 plus 4, which is 20. So that's the square root of 20 divided by 2. Now, how do I simplify this? This is going to be an irrational number, right? Because I've got the square root symbol here, and I know that 20 is not a perfect square, so I take 2 plus or minus the square root of 20. I look for perfect square factors of 20. That's a 4 times a 5. The square root of 4 is 2 times 5, and that gives me the 20 that I had here, and I divide that by 2. I can simplify this further because I know that this 2 in the denominator divides into both of those 2's up there. So this is 1 plus or minus the square root of 5. Ugly, right? But that is, in fact, what I have. Now let's go back and rewrite this. So I'm going to come way down here, and I'm going to rewrite this as f of x equals my original factor from the table, x minus, oops, I'm going to scoot that over for a second. I'm going to put my 2 in here so I don't forget it. 2 times my 1/2 from the table times this new factor, which is x minus 1 plus the square root of 5, and x minus 1 minus the square root of 5. So it's minus the 1, and one time we put plus the square root of 5, and one time we put minus the square root of 5. So these are the factors that I have. Now let me go back and look at the directions. The directions said that I wanted to solve. So this is the polynomial in its factored form, and if I wanted to give you the roots or solve it, that would look like 1/2 and 1 plus or minus the square root of 5.